Alright, so this section is really just setting us up for what we're doing in the rest of this unit. We're going to start doing hypothesis testing. And this section is really just what does it mean, getting used to the notation, that kind of thing. So we're not really doing any math today. We're just talking about what things mean. So first, right after I said we're not going to do any math today, we are actually going to work one problem. I guess I should have held that thought for just a second. So a friend wants to play a simple coin flipping game. If the coin lands heads up, you win. If it lands tails up, your friend wins. Suppose the outcome is 5 tails. Is your friend cheating?
Of course he is.
I don't have very much faith in your friends.
It's a loaded.
Are we gonna test it or something?
It's a
To see if
weighted.
it's unusual.
It's weighted to the heads.
So how do we find the probability of that? So the probability of tails is 1/2. Are they independent?
Yes.
Yes, so just to the 5th power. And what does that give us?
0, 3, 1, 2, 5.
So do you think your friend's cheating?
Absolutely.
Absolutely. You have a shady group of friends. So I would say from this, either our friend is cheating. Is it possible though?
Yeah.
Yeah, so or is very lucky. Okay, we know that would be highly unusual, but not impossible. So it would make us very suspicious if they were cheating, but not necessarily proof of it yet. So hypothesis testing is kind of what we do when we make an assumption and we're seeing, can we prove that this is right or not? When we're talking about hypothesis testing, hypothesis is just a statement you are making about a characteristic, or like the probability of getting a tails in this case, or something like that. So some examples of what a hypothesis might look like. In 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes this percentage is different today. Or according to a study published in March 2006, the mean length of a phone call on a cell phone was 3.25 minutes. A researcher believes that the mean length of the call has increased since then. So you notice both of these have like a baseline. We have some previous estimate that we're using, and then we are estimating that it has changed, or it's gotten bigger, or it's gotten smaller. When we are doing these, would I even need to do a hypothesis test if I had a study that found the average phone call length right now? No. The only point of doing this is if we don't have the actual data. So if you have the population data, there is no need for this. The only time this is useful is if maybe I have sample data and I am trying to make some estimate about the entire population. So this is called inferential statistics. We are not describing what we have. We are trying to make some guess. We are inferring something about the group as a whole. So hypothesis testing is basically a process where we are going to look at a sample evidence and test statements about the population. So our steps will always make a statement regarding the nature of the population, collect our evidence to test the statement, and analyze that data. This is going to be an ongoing thing. We're going to do a lot of hypothesis testing in the weeks to come. Today what we're going to focus on is our initial statement when we're doing this. We'll have what's called a null hypothesis and an alternative hypothesis. So the null hypothesis will have an H sub 0. That is the statement to be tested. That's usually your previous study, or the probability of getting a tails is 1/2, or based on the study, the average was this amount. The null hypothesis is assumed true until the evidence indicates otherwise. The alternative hypothesis will have an H sub 1. That's a statement we are trying to find evidence to support. So when we set up our hypothesis testing, we will always have an H sub 0 and an H sub 1. Our null and our alternative hypothesis. And essentially what we're doing is assuming the null hypothesis is true, and then finding the probability that the alternative occurs. And if that would be unusual, like when you flip your coin 5 times and you get a very unusual result, 0.03125, then we might say, okay, that's very unusual, so that null hypothesis probably was not true. Okay, so we assume the null is true, and we're going to be trying to prove the alternative. And we have 3 different ways we can set it up. The null hypothesis will always be your H sub 0 is always going to have an equal to. I should probably write that a little differently. I might say the mean is equal to something, or a p hat is equal to something, depending on my variable, but it'll always have an equal statement. So the null is just equal to a value. The alternative, you have 3 different options. It could be less than, it could be greater than, or it could be not equal to. Those different options are considered two-tailed, left-tailed, and right-tailed. Okay, so a two-tailed test, your null is equal, your alternative, it's not equal. So it could be less, it could be greater, so it's two tails, it could be either end. If it's a left-tailed, the null is always equal, the alternative is less than, it's something to the left, it's less. And then a right-tailed test is greater than, something to the right, it's something greater. So let's try to write some hypotheses. I want the null and alternative hypothesis for each. And then we're going to identify if it is two-tailed, left-tailed, or right-tailed. In 2008, 62% of Americans regularly volunteered their time for charity. A researcher believes the percentage is different today. So, my null hypothesis is what? That's 62%. Okay, we need to pick an appropriate variable. If I'm talking about a percent, is that like a mean or a proportion? So we could say the proportion is equal to 0.62. Then the alternative, if it's different, that means it could be less, but it could be greater than. So what would my alternative be? Not equal to. So is this left-tailed, right-tailed, or two-tailed? What is my parameter on this? I didn't ask that, but the parameter is just the thing we're talking about, which in this case is our p value. Okay, so our parameter might be a proportion, it might be a mean, something like that. Okay. According to a study published in March 2006, The mean length of a phone call on a cell phone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. So the null hypothesis is what? The alternative
It's greater than 3.25.
is this left tail, right tail, or two tail? Greater than is to the right. What is my parameter on this problem? Alright, you guys try the last one. So, what's your null hypothesis?
Standard deviation equals 0.22.
And the alternative hypothesis?
Standard deviation is greater than 0.22. Oh, less.
Left, right, or two-tailed? The parameter we're testing this time is? So do you guys feel like you could read a problem and write the null and alternative hypothesis for it? So, we are trying to, or we will be trying to look at hypotheses and make some kind of conclusion. But we know we're not always going to be right. We make mistakes, or, we say something, we look at the probability of something happening, like our friend getting 5 tails, and we're going to assume that he cheated because it's so unlikely. But is there a chance that he wasn't cheating? Yes. We have to draw some kind of conclusion, but we know that it's not impossible for him to win that game with 5 tails. So even though we are assuming that he was cheating, there is that slight chance that he wasn't. So there is always error associated with this. So there's 2 kinds we're going to talk about throughout these coming chapters, type 1 and type 2 error. So when we do a hypothesis test, we're basically trying to decide if our alternative hypothesis is true or not. So type 1 will be when we reject the null hypothesis and it was actually true. So it would be like me saying, okay, I do my test and I have evidence to believe that the mean or the proportion is not 0.62. I'm rejecting the initial hypothesis, but I'm wrong. That's why it's called error. So I really shouldn't have. Type 2 is the reverse. We don't reject the null, but the alternative was actually true. So it might be me doing this test and saying, I don't have enough evidence, I'm going to stick with the null hypothesis being true, but it actually wasn't. Alright, so, hard to keep them straight. What I remember, type 1 is when you conclude the alternative, H1, is true. Type 1, you're concluding H1. But the whole thing with error is you're mistaken. Okay? We concluded the alternative, but we were wrong. So then type 2 is the opposite. It's when you conclude the null. H sub 0 is true. We will have, throughout the chapter, we'll be talking about an alpha level of significance. That's basically the probability of a type 1 error. So we'll look at that more later on. So I want to try just writing these conclusions, making sure we can kind of understand what they are. For each of the following, we are going to explain what it would mean to make a type 1 error and a type 2 error. Okay, so this is going back to the first two examples, the A and B on example 2. Okay, so on example 2, we said the null was the proportion equal to 0.62. The alternative proportion was not 0.62. So type 1, that means we conclude H sub 1. So that means we are agreeing with the alternative.
So the population is 0.62.
So the researcher concludes the proportion was not 0.62 when it actually is. Just remember, the whole thing about this, we're wrong. So we concluded the H sub 1, we concluded the alternative hypothesis, but we made a mistake. Type 2 is the reverse. So you're concluding the null. So the researcher concludes the proportion is still 0.62. When it is not. You guys try the second one. Can you explain what type 1 and type 2 error would mean? So remember, from when we did this example, the null hypothesis was the mean is 3.25. The alternative was that the mean is greater than. So what would type 1 error be? Concludes greater than. Okay, and the reason this one's greater than versus not equal to was the difference in the alternative hypothesis on those problems. What would type 2 be? So we conclude the mean is still 3.25, and it is actually greater. And again, I'm saying greater because my alternative hypothesis was greater than. All right. Any questions there? Okay, so with hypothesis testing, we are basically trying to decide if the null hypothesis is still accurate or not. But we're never going to say we accept the null hypothesis. Okay, we're not actually testing if that's true. We're testing if the alternative one would be true. So the language with these, we're not going to say we accept this or anything like that. We're going to say either we reject the null hypothesis if we have proof that the alternative would be true, we would reject. Then if we can't reject, we just say we fail to reject. We're not actually proving that the null hypothesis is true. Because we can't. We don't have the entire population, so our options are reject or fail to reject. So if I look at this one. According to the study, the mean length of a phone call was 3.25 minutes. A researcher believes that the mean has increased since then. So that's the example we've looked at a couple times. Remember, we wrote down that the null, then the mean was equal to 3.25. The alternative on this one was the mean is greater than 3.25. So part A. Suppose the evidence indicates that the null hypothesis should be rejected. State the wording of the conclusion. So when we do hypothesis testing, you will have to write a sentence at the end telling me what we are concluding. So what we would say is there is sufficient evidence to conclude. Okay, so we're rejecting the null, we're going with the alternative. The mean length of a call is greater than 3.25 minutes. If I do my experiment and my evidence says the null should not be rejected, I am not saying that I have proven the mean call is 3.25. That's not what we tested. We were testing if the call was greater than, and we can't prove that, is basically what it means. So we would say there is insufficient evidence to reject the null hypothesis. So I'm concluding the average is still 3.25, but I'm not saying that I proved it was 3.25. I'm saying I didn't have enough evidence to prove that it's not. I couldn't prove that this was false, so I have to stick with that. Okay, we had a reason to believe it used to be this. If I can't prove that's no longer the case, we have to continue to assume this is still true. Any questions there? Tomorrow we will actually do some hypothesis testing. Today it's really just getting used to the language of it. So that is the end of this section, and I have a packet for you. So just like we've done the last few chapters, I kind of liked how that worked out, seemed to go well. I put together a chapter 10 assignment